Find a possible equation in terms. So we need A and B. A comes from the what? A comes from the what? Amplitude. So if we get the amplitude of this one, it's from -3 to 3, which is a distance of 6, and half of that is 3. So we're going to go y equals, and I'm going to tell you for this one that A is greater than 0. So we're going to do +3. Then sine, now I need B. B is the horizontal stretch factor, correct? It comes from the period of the graph. The period of a normal cos graph is 360 degrees, correct?
Yes.
The period of this one, I'm going to start at the y-axis, and then I'm going to go past the max, past the min, back to that same height to find out how long it takes to repeat itself. So I'm going to go past the max, past the min, back up to that same height, and then what happens after that? It repeats. So how long horizontally did this take to happen? 180 degrees. So what's my horizontal stretch factor?
2.
My horizontal stretch factor is 1/2. My B value is 2. So you can either visualize it in knowing that it has to half. If it has to half, then this needs to be a 2. Or if we want to find P equals 360 divided by B, that's a formula we can memorize. Or these flop, these can switch. So B equals 360 degrees divided by P. And what was the period? It was 180. So 360 degrees divided by 180 degrees. The degree symbols cancel and it's 2. Right? So B is the period. It's a made-up thing. It's not real. But it's not the period. So you can't put the period in the B spot. Call it the period as a joke.
How do you know it's 180?
Because from here to here, horizontally, how long it takes. So from here to here to here is how long it takes to repeat itself, correct?
Yeah.
And then I'm going from 0 to 180.
Oh.
So that's a distance of 180 horizontally. Yeah? All right. What about this one? How do I get my A? Amplitude? Yeah, so min -2, max 2, which is a distance of 4. Distance of 4, so I divide by 2 and I get 2. And we're going to say A is greater than 0 because it is. That you'll learn in a second. So we're going to do y equals 2 cos. Then I need to figure this out. So now I need to go, remember if I start anywhere and I go past a max, past a min, back to that height, it works. What I can also do to get to a period is go from a max to a max or a min to a min, correct? So this one, we're going from a max back to a max, which is a distance of how much? 720. So what did I do? I doubled the period. So what's my B? 1/2. Or you could put theta over 2 as well. Because that's the same as multiplying by 1/2. Now, if that doesn't ring a bell, you can do B equals 360 degrees divided by the period, which was 720 degrees, which equals 1/2. Right? You can't just use the formula. Yeah? All right. Next page. So we want the period and the amplitude. We'll just do it for these two. So what is the amplitude for this one? How long does it take me to get from min to max? What is that distance? 1. So what's the amplitude? 1/2. And then we have to figure out the period. I like starting on the y-axis if possible. If on the y-axis I have a max, I go to a max, correct? If I have a min, I go to a min. If I don't have either, I have to go past a max min to get to it. So I'm starting here. I go past a max, back to that height. What do I still have to do? Past a min, back to that height. So what's the period? How long did this take me? 2 pi. So my b value, which it did not ask me for, would be 1. Because it didn't stretch at all. Yeah? Oh wait, let's look at this one. Amplitude from here up to here. What's that a distance of? 2. So what's my amplitude? What's half of 2? 1. Amplitude is always positive as well. Your A value might not be positive, but your amplitude is. And then the period, I start on my y-axis. On my y-axis, I actually have a what? A maximum. It did start with an M, I'll give you that credit. So we had a maximum on our y-axis, so we have to go till we get back to a maximum, which is 2 pi over 3. Now this is the one that people find a bit harder to figure out what b would be. Nope, I don't know where you're going with that, but b would just be 3, because I would have to multiply this by a third, correct? Put it back in. Now say your brain matter falls out, doesn't matter. b is 2 pi over the period, correct? So b is 2 pi, technically divided by 2 pi over 3, which is 2 pi over 1 times 3 over 2 pi. And then the 2 pi's cancel, and it's a 3. Right? You try these two. So from here, our amplitude is what? What is the amplitude for this one? 2. And then the period, I start from a max and go up to a max. How do we know what this tick is? Remember how we did it? We went 2 pi and then counted how many there are. 1, 2, 3, 4, 5, 6. So this is 1 pi over 6, 2 pi over 6. This would be 3 pi over 6, which is actually pi over 2. This one, we start at the x-axis, go past a max, back to the x-axis, and then we have to go past a min, back to the x-axis. Do you agree? So how far is it from here to here? 3 pi. And what are we going to have to do to that? Double it. So the period is 6 pi. Also, this one from here to here is 1.5. What would it be from here to here? 1.5 because of this crossing here. And because there's no vertical stretch or vertical shift any. So our amplitude is 1.5. Okay. You do 2 pi divided by period. So it'd be 2 pi divided by 1.5. So I didn't ask for b, I just asked for amplitude period. I was just explaining that. Okay, over here, transformations. Woo-hoo. So our normal sine and cosine graphs are a sine b x minus c plus d. Remember, we still need that 1 in front of the x. If we don't have it, we have to make sure that we actually get it having a 1 in front of our x, or our horizontal translation will be wrong. Now, trig, there is one catch. Instead of vertical translation, only for trig, not for anything else, instead of vertical translation, they use the word vertical displacement. Too bad, so sad. I don't mind it. And then instead of horizontal translation, for the C and the D's here, it would be great if it was horizontal displacement, because then you do the same words. It's not. It's horizontal phase shift. My favorite is when phase is spelt with an F. It's not, but it does happen. So vertical stretch sounds the exact same. Nothing changes. Reflections are the same. But vertical translation and horizontal translation are vertical displacement and horizontal phase shift. All right. So here we're going to state our transformations first. So what we're going to do to help ourselves out is we're going to line this up and make sure there's an A, a B, a C, and a D. Okay? If A and B are missing, they're ones. If C and D are missing, they're zeros. Okay? So for example, I don't have an A here in front of my sign, because remember it has to be in this format. So I'm going to label it as a 1. If it was a 0, the whole thing would cancel, right? So 1 sine, I don't have a B because B is what falls between sine and x. So I get a 1. I don't have a C. Some people are like, yeah, I do. I put brackets. See, I have a C. I'm like, you put the brackets. They're like, yeah, I did. I'm like, no. Bad. So if you want to put brackets, you could only put them there. You can't just make them bigger because you feel like it. So this would be 1 x minus 0 technically plus 3. So do you see when there isn't a C, you can make it a 0. A's and B's have to be 1s. So what's the only thing that happened here? Vertical displacement. And the y's always stay the same. So vertical displacement, 3 units what? Yeah. 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 It doesn't matter. No. Okay, mapping. Mapping is xy becomes x what? Yeah, mapping and words are the same, right? So if we're going up 3, we have to plus 3. We're going to look at this one. Once again, that's a D again, right? So we would have y equals 1 cos 1 x minus 0 plus 0, doesn't really matter, minus 2. Do I have to write it out this way? No. I do because at the beginning you guys don't know what anything is. Okay? So that's that one. Let's look at this one. Now what is it going to be? Y equals 3 sine, what goes in for my B? 1, what goes in for my C? Minus 0 plus 2. Okay, we're going to do that for each of them. What about this one? Y equals negative 2 cos. Put a negative. Put a negative. 1, then what? Yeah. Sure. No matter. And then the next page. I really need to print the notes you guys have for your face. Okay. You have this?
No. We just don't have the plus 2 at the end.
This is
Oh,
gone?
never mind, that's completely wrong.
It's totally out to lunch?
It's completely wrong. Like, unless you have
Oh, wait, we have y equals cos x minus pi over 2. So we're going to get y equals 1 cos 1 x minus pi over 2. And what's our d? Plus 0. Oh, I was nice to you guys for this one. For 6 and 7? No, they're the same. But 6 is nice. Your guys' isn't as nice. What is happening here? Yeah, it's not the same y. It is the same. It's just not the same yet. What do I not have in front of my theta?
1.
A 1. So I have to take that out, correct? I did take it out on your example. So it's going to be y equals sine 1/2 theta minus what? 30, because when you take a half out of 15, it's like multiplying by 2. So we have plus 0 at the back and a 1 at the front, right? Same thing here, 1 and a plus 0. So what I want you guys to do for them is I want you to go to this next column and I want you to write down all the transformations and the mapping for all those examples. So transformations and mapping, just like I did here, except I picked the easiest one. You're on. Go. Oh my gosh. It's a plus?
Yeah.
That's what mine is too. I believe in you. I just changed it. This totally was a plus 30 the whole time. What were you thinking, Alex? I can't go back. Now everyone would have to make it a plus. Okay, go. This one has a vertical what? Vertical what? Displacement. Check and see if you wrote translation, because you ain't right. Vertical displacement, 2 units down. Mapping x, y becomes x comma y minus 2. Then this one, you have a vertical stretch by a factor of what? Don't all answer at once. Factor of 3. About the x-axis. Verticals never change, right? And then we have a 1 and a 0, so nothing there. And then we have vertical displacement. 2 units what? So my mapping is going to be x, y becomes x. Nothing happened to my x's. My y's are multiplied by 3 and then add 2. Okay, this one has a vertical displacement. Nope, that's a lie. It does, but that's not where I'm going. Vertical stretch by a factor of what? No, I have it. Factor of 2 about the x-axis. These two you can do the multiplication. No. Reflection in the x-axis because it's with the y. And a vertical displacement. 3 units what? 3 units down. So we get x, y becomes x. Nothing happens to my x, and my y's are multiplied by 2 and subtract 3. Okay, then we're going to flip over. Okay, this one has a horizontal what? Phase shift. Pi over 2 what? Right or left? Right. Now the catch here is C is in radians, correct? If you're given a C value, you know if the equation's in radians or degrees, this one would be in radians. Okay, and then mapping would be x, y becomes x, comma, that's a lie, x plus pi over 2, comma, y. Now, the period of this graph would be, is there a horizontal stretch at all? Is there a b value? No, so the period is 2 pi, right? And why would I know it's 2 pi and not 360? Because C is actually in radians. Okay, this one, we have a horizontal stretch. By a factor of what? 2 about the y-axis. Remember, x's be crazy. They do the opposite, right? And then this one is in degree mode now. Because look, C is degrees. So horizontal phase shift 30 degrees left. Is don't have to write units because the unit is degrees. Some people write 30 degrees units. The unit is degrees. Okay? And then our mapping is x, y becomes, words and mapping is the same, so I have a 2x and then 30 left, so minus 30 degrees. Use the degree symbol, y. And then this one is a horizontal stretch. By a factor of 1/3. About the waxes. And the horizontal phase shift, pi over 2 units what? We could say pi over 2 radians if we wanted to, so. Or units, doesn't matter. Radians, which way? Right or left? So our mapping is xy becomes 1/3 x plus pi over 2 comma y. Finish the rest of this tomorrow, but what we're going to do is I'm going to give you just a couple questions to do out of your textbook on transformations so that you can finish them now, and then tonight you can finish your what? Handed. What did you come to me and say, Mrs. Lepp? I left it on my desk. Mrs. Lepp, my dog ate it. Mrs. Lepp, I didn't have time to finish it, even though you gave it to us way, way, way earlier in the week, and for some reason I decided to do nothing. Mrs. Lepp, I came down with the worst flu. I ate raw chicken so that I could puke, so that I couldn't no, you didn't. Okay, so what I need from you is your handed in tomorrow without an excuse. See? It's easy. It's no big deal. Tomorrow. Your face right now does not help my cause. That is the homework. One of them is just says vertical, and then this term the phase shift and vertical displacement. I want you to just state the transformations for any of them.